In this video, we'll look at the pre-calculus topic of solving quadratic equations. To start with, it'll be helpful to be clear what a quadratic equation is. Quadratic equation is in this form: ax squared plus bx plus c equals 0, or it could be ax squared plus bx equals c, or so on. But the key here is that the degree is 2. There's an x with a power of 2, and there's not an x with a higher power of 2. So that's an example of a quadratic equation. There are 4 ways that we're going to look through on how to solve a quadratic equation. The first way that we learn to solve quadratic equations is factoring. Maybe you recall solving by factoring. That's where you, let me get the highlighter on here. You would set the equation to 0, and then you would factor the left side, the one side that's not 0, and then you set each of the factors to 0 and then solve those 2 equations. That's how we use factoring to solve a quadratic equation. You could also use the square root property, and that's where you isolate the x squared term, isolate the square, and then we take the square root of both sides. After you take the square root of both sides, and there's a little bit more to it, but this is in general, and then you'd solve for x. Completing the square is actually going to rely on the square root property. But the square root property is what we can do when it's easy to isolate the square. Sometimes you get a quadratic equation where the x's are not all grouped together in a perfect square. So taking the square root of both sides doesn't really work. So what we do is we manipulate that equation to make it fit, squeeze it into the format we want. So then we could square root both sides and solve. So we manipulate the equation and then use the square root property. And then finally, the formula. I hope you know what the formula I'm referring to is. It is the quadratic formula, right? Now, you may be accustomed to using the quadratic formula, but what I'm going to ask you to do as you use the quadratic formula, just to get started here, and then eventually, if you're getting every one correct, you could drop some of these steps. But as we get started, here's what I'll ask you to do when we're using the formula. I'm going to ask you to state the formula. X equals, and so on, right? And then I'm going to ask you to state what A, B, and C are. Fill in the values we have for A, B, and C, and then solve. For now, you might just jot down those steps. When we get to more detail of using the formula, then you could walk through those steps. But for now, maybe just jot those steps down. Are you ready to jump in and try some of this? Let's look at solving by factoring. For this first example, what we've got to do first is make sure it's set to 0. And this one is, in fact, set to 0. So now we're going to factor the 3x squared plus 12x. You might look at that and think, oh, I don't remember how to factor that, because it's not 3 pieces, it's only 2. So let me remind you that what we're going to look at here is factoring out the greatest common factor. The biggest number that goes into both a 3 and a 12 is a 3. And the highest degree of x that goes into both is an x. So our GCF is going to be 3x. If I divide both of these by 3x, then I'm going to get 3x squared divided by x is x. 3 over 3 divides out. X squared divided by x divides to x. And then 12 divided by 3, if I'm going to do 12x divided by 3x, 12 divided by 3 is 4. And then x divided by x is 1. So I'd get, if I divide out the 3x, the GCF, I'd get x plus 4. So how do I apply that to factoring? I'm going to factor this by saying that the GCF was 3x. And then 3x squared plus 12x is 3x times x plus 4. I hope that helps remind you a little bit about how to factor. So 3x times x plus 4 is equal to 0. If you need a little bit more review on factoring, then I'm going to insert some other videos, and I'm going to encourage you to do a little bit of your own factoring review. I'm doing a very brief factoring review, but you may need a deeper factoring review, and that's okay. Just make sure you get that extra review if you need it. Once we've factored the left side of the equation, so we started by getting it set equal to 0, and then we factored. What we're going to do next is state that each of these factors is 0. Now the reason we do that is that we're looking at this. If a, well, let's not even use a variable. Let's make it even easier. Just some number times some number is equal to 0. Then what we know must be true is that either the first or second or both must be a 0. If this first factor is a 0, then 0 times whatever the second factor is would equal 0. Or if the second factor is a 0, then the anything times that 0 would equal 0. Or if they're both 0, 0 times 0 is still 0. But what we do is we set each of the factors, the 3x and the x plus 4, equal to 0. When I set those to 0, I could divide both sides by 3, and I get x equals 0 over 3, which is 0. Now don't be afraid of a 0 in the numerator of a fraction, although a 3 over 0, 3 divided by 0, is undefined. A 0 over 3 is okay, it's just a 0. So we have one solution is x equals 0. The other solution, x equals negative 4. And that's our first example. Let's try this next one. The first step is to set it equal to 0. So I'm going to subtract 8x and add 15 to both sides so that I can move those over to the left. What I would get when I do that is I'd have x squared minus 8x plus 15 equals 0. Let me show you that. If I subtract 8x from both sides and add 15 to both sides, then the left side of the equation gives me what I have shown here. X squared minus 8x plus 15. And the right side, the 8x minus 8x cancel out. 15, negative 15 plus 15 cancel out to 0, so that's where that 0 comes from. All right, so once we have it set to 0, we're ready to factor. When I factor this, I'm looking for two numbers that when I multiply, I get 15. And when I add, I get a negative 8. So I'm thinking 5 and 3 multiply to 15, and then negative 5 plus negative 3 add to negative 8. So these two values, the negative 5 and the negative 3, are the two numbers I'm looking for. So when I factor this, I could have x minus 5 times x minus 3 equals to 0. I can check that with a quick FOIL. First times first, outside times outside, inside times inside, last times last. And sure enough, I get x squared minus 8x plus 15. So I know that my factoring's okay. That's just an aside that you never hurts to check your factoring before you go. Remember the next step of the factoring method of solving a quadratic? I'm going to set each factor, the x minus 5 and the x minus 3, I'm going to set each of those to 0 and solve. The first one I'll solve by adding 5. So I get x equals 5. And then this next one I get, I'm going to do plus 3. So I get x equals 3. It looks like our two answers are x equals 5 and x equals 3. You know, it wouldn't hurt just to finalize both of these examples to write the solution set, to say therefore the solution set is -4, 0. If I want to be really proper and precise, I'm going to put those in order. So I'm going to put the smaller one, the -4, first. And then the solution set for the second example is going to be set of numbers 3 and 5. That's a nice way to write the final answer. Let's look at the next way of solving with the square root property. It's to isolate the x squared and then do the square root of both sides. So if I isolate the x squared for 5x squared plus 1 equals 51, I'm going to start by subtracting 1 from both sides, and I get 5x squared equals 50. And then I can divide both sides by 5 to get x squared equals 10. So there I've got the x squared term isolated. The next step, you got to be a little bit more thoughtful about this next step. I want to isolate the x. I want to get rid of the squared. So to undo squaring, what I can do is the square root. Now we know that when we are working with an equal statement, so an equation, whatever we do to one side, we have to do to the other side also. So I'm going to do the square root of 10. But here's where you have to be thoughtful. You know, I'm going to just write it in for now, and then I'll go back to show you why. You want to get in the practice of always, when we do the square root of both sides, say we're looking for the positive or negative value. So what we'd get is the square root of x squared is x. And the square root of 10, that doesn't simplify. So we would just have the negative square root of 10 and the positive square root of 10. But let's take just a minute to look at why we do that. Now, if I did this easy one, x squared equals 25. If we did this just mentally and thought, well, what could I multiply by itself to get a 25? I know that I could do 5 times 5. But do you see that hidden example that's hiding underneath the surface? That I could also do a -5 squared, because -5 squared is also 25. So I could see here that x could be 5 or x could be -5. So that example might help you recognize why we've got to do the plus or minus. Let's try this next one. First step is to isolate the x squared term, so I'm going to add 5 to both sides. I have 2x squared equals 55, negative 55 plus 5, so negative 50. Divide both sides by 2, and I've got x squared equals negative 25. Not the answer, so I didn't mean to box it, but I'm going to bubble that because we've got the first step there. What we have is the x squared term is isolated. So now that the x squared term is isolated, what I'm going to do is the square root of both sides. So I've got the x squared on one side and the negative 25 on the other. When I do the square root of both sides, I'm going to remember that this is the positive or negative square root. Square root of x squared is x. The square root of negative 25, you remember from complex numbers, our last video, if you skipped the last video, the videos, 2 videos for 1.4, maybe go back to that because it's covers why we have this I, but it's a 5i and negative 5i. So if I write the solution set, I could say negative 5i and 5i. Those are the 2 solutions. One more example. Let's look at this last one. Cleared the space a little. If I isolate the x, I'm going to divide by 3 first because I can't do anything with this negative 4 that's inside the parenthesis. 15 divided by 3 is 5. And now I actually have the x term, the squared term rather, isolated. So I'm going to do the square root of both sides. And when I do that square root of both sides, I'm going to remember to do the plus or minus square root. When I do that, the square root of x minus 4 squared, that square and square root undo each other. So I'm left with x minus 4 on the left. And then on the right, I have the plus or minus square root of 5. We're almost there. To finish solving this for x, I'm just going to add 4 to both sides. And here's what that would look like as a result. We'd have x equals 4 plus or minus the square root of 5. X equals 4 plus or minus the square root of 5. So our solution set would be 4 minus the square root of 5, comma, 4 plus the square root of 5. Four plus the square root of 5, comma, 4 minus the square root of 5. Well, I hope that this video has helped you get a better understanding of the factoring method of solving a quadratic and the square root property to solve a quadratic. I'm going to stop this video here and say if you have any questions, then I hope that you'll reach out to me and let me know. Let me see if I could get to the last screen here. If you have any questions, let me know. And if you, after you take a break, if you want to watch the next video will cover the quadratic formula, which many of you may find easy. Maybe you've already familiar with that. And also completing the square. And completing the square tends to be one of the topics that students struggle with the most. That's why I'm going to take a short break before we jump into that topic.